Welcome to the ABC Retreat 2020 with the title Heuristics and Education. The ABC Retreats are a wonderful opportunity to get together, exchange ideas about decision-making and uncertainty, about the nature of rationality, about heuristics and its applications. The retreats exist since 1995, so it's now 25 years. And it is a kind of family reunion with ever new faces turning up in the family. And you are all welcome to join. And the retreats provide an opportunity to get together, get close together, discuss ideas, play, and also make music face to face. Not this year. A virus has led to travel restrictions, which kept many of us being just virtual here, and from China to the UK, from the US to Berlin. And many had to stay home. I regret this lots. And I hope it's next year that we can all be together again. Nevertheless, it's the great achievement of Laura Martignon, helped by Joachim Engel and many others, including her brothers, to make this retreat possible. And it's also a great tradition that we had last year with the retreat in Constance, and the year before with the retreat in this beautiful Swiss mountain hut organized by Ulrich and Julian. So I'm very grateful that these retreats are happening. And so I have been spending the last year on some issues closely related to education. And there will be a paper coming out in the Journal of Experimental Psychology General with the title, Do Children Have Bayesian Intuitions? Where we for the first time showed that we can already, second grader, at least some of them, with icon arrays, elicit Bayesian intuitions. That means that they precisely estimate the Bayesian posterior probability that has never been shown before. And equally striking, icon arrays, which is a kind of visual form of natural frequencies without numbers, can also help people diagnosed with dyscalculia to do Bayesian inference, which suggests that the problem is not a genetic one, but it's in the representation. They do not seem to understand Arabic numbers. And if you have a no number representation, that works. Another thing I've been doing that is related to education is I'm finishing a trade book on called How to Remain Smart in a Smart World, which it's a kind of continuation of Risk Savvy, but applied to the digital revolution. And I plan to finish it in a month or so, and it will then be published sometimes at the beginning of next year. So, and also the work with the Bank of England on how to make the world safer by using simple heuristics as opposed to complex methods that overfit. Is now being published in the Journal of Industrial and Corporate Change. So that's 4 ABC people and 4 people from the Bank of England. So that's just a few ideas to keep you, from my side, on track. And we begin our program today with 2 books that also will be out early 2021. And the first one is called Classification in the Wild. This is a joint work between Konstantinos, Oscar, Marcus, and myself. And we spent much time somewhere in British pubs and in Berlin, when they still could travel to Berlin, and other places, and have tried to get together two traditions, that is machine learning and heuristics. And we focus on fast and frugal trees and tallying, and Konstantinos will give you much more detail in a few minutes. And ask the question, can we identify situations where it pays to do complex machine learning? And can we identify a situation where it pays to do, say, fast and frugal trees? And it has lots of interesting applications. And also it's the first book that is a hands-on book that everyone can learn how to construct a fast and frugal tree from first principles. The second book that is coming out and will be presented afterwards is a handbook on bounded rationality edited by Riccardo Viale. And many people from ABC are contributors, signaling that there is a change now from thinking about bounded rationality as a collection of cognitive illusions to one in the tradition of Herbert Simon. So Simon's idea was bounded rationality is the study of human behavior in situations of uncertainty, as opposed to risk, where risk is defined in Savage's word by a situation where you know the entire future states of the world, so the mutually exclusive and exhaustive set of states, you know all the consequences and hopefully all the probabilities, at least can estimate them. And these situations exist like lotteries, or if you play the roulette, you know everything that can happen, 36 numbers in green, and nothing else can happen. And you know all the consequences and probabilities. But many problems that we face are not of the kind and about uncertainty. And they need different tools. So although the concept of bounded rationality has been around since more than 50 years, there are actually three different concepts. So Simon's idea has been more or less occupied by two other ideas that are hardly compatible with Simon's, and also which contradict themselves mutually. So Simon's idea is study what people do under uncertainty. The economist's idea of bounded rationality is don't study what people do, study as if models, so expected utility maximization, and not under uncertainty, but typically under situations of risk, where all the states are known, all the consequences are known. And as Reinhard Selden once put it, the question is, assume you are God. The question is, how would you behave? That's not what Simon had in his idea. And the third idea of bounded rationality is, in one sense, similar to science. So that's the heuristics and biases program. So study what people do, although it lacks formal models, unlike Tversky's earlier models. But then it is also a study under situations of risk. So it takes Homo economicus seriously as the model in all situations and looks at deviations of people and then puts the blame on the people and not on the model. So the fast and frugal heuristics program is in the tradition of Herbert Simon. And we are looking at process models, not as if models, and we extend the study of decision-making under risk to decision-making under uncertainty. And there's plenty of uncertainty in our lives, as the present crisis amply demonstrates. So with all of that, I hope you have an inspiring time. You get new ideas, and remember, having the right questions is more important to having the right answers. Having the right answers to the wrong question is known as the type 3 error. And you don't want to commit that. Similar as like confusing a situation of uncertainty with one of risk is known as the turkey illusion. And so these are very simple concepts that may remind you that there is, you need basically think along, and not just do what everyone else is doing. So I thank you very much for being here in person. And I see many happy faces being in Ludwigsburg in person. I see also happy faces on the Zoom screens. And I'm looking forward. I'll be all the time with you. And we will start with the 2 books today, and then move to Beijing, to Konstanz, to Ludwigsburg, to Freiburg, to Regensburg.
It is?
I think, yeah, so you're sharing.
But I was sharing before and they could see weird
But
stuff.
now it's working.
Now it's working? Perfect. Okay. All right. So these are the joys of doing everything online these days. So hello, everyone. Thank you, Laura, for organizing this lovely conference, which Oscar and I couldn't attend, but hello from Bath. And thank you, Gerd, for the introduction. We do not have the book cover yet, but we have completed the final proofs. And what you see in this screen, hopefully, is the title page, the first page in the book to the left, and to the right, you see the table of contents. I took the initiative without really consulting the other authors to not have a very technical presentation. I didn't want to be overly dry and simply go through all the chapters. In the end, I'll put this screen up again and quickly tell you what's in each chapter. After, it will make a little more sense to you after you've seen some examples, and then we can have a discussion. Okay. So the first thing we wanted to do is to acknowledge our 4th co-author who couldn't be here. And this is Marcus Bookman. He was Oscar's PhD student at ABC. And now he's a senior data scientist at the Bank of England. Okay. I speak normally. I think Oscar hears me normally, so I don't know what else to do. If it's very bad, stop me and I can repeat something. Yes, you cautioned me, Laura. So I will do 2 things. In the slides that you will see is demonstrate what the wild is and what we can do for the wild. And we're demonstrating here what the wild is with a very English problem in the little island that we're living. Will it rain in the next 5 minutes? And how will the weather be in the next 10 minutes and so on, because it's always changing. Than that. Uncertainty keeps changing, and it keeps changing in ways that are unpredictable. So the way in which the future is uncertain may be very different from the way that the past was uncertain. You can see it in the probability of rain if you look at your smartphones and you see that these probabilities keep changing. It's also not clear at all what these probabilities mean. And of course, if you are in a domain such as wealth, health, or justice, then it's even more clear. We think that uncertainty cannot be meaningfully reduced to probability. So this is the wild. The main thesis of the book is the following, which Gerd touched upon. We want to complement the existing models from cognitive psychology, operational research, and machine learning, and propose new models which are simpler. And we want to propose models which lead to fast decisions, transparent and accurate decisions. So a little more specifically here in italics, that's the main thesis of the book, the thesis we examine. In the wild, simplicity and accuracy are not necessarily enemies of accuracy. Yes. Thank you. And what we do in the book, we consider several empirical cases and then present an analytical theory. So I will only present the cases in the next few slides, and this is what we propose one can do in the wild. So the first example, this is Nate Silver's 538 webpage, and it's their prediction for the previous presidential election in the US between Hillary Clinton and Donald Trump. So the overwhelming prediction in terms of probabilities was that Hillary Clinton will win. And the way they did that was by a heavy mix of statistics and machine learning models. It was in many ways a regression upon the results of regressions. And they, without really paying attention to more than patterns. So they didn't really have a theory of the psychology, sociology, economics that underlies voting. That's one way of doing it. Another way of doing it is what Alan Lichtman did, who is a professor of history. And he did a deep analysis of all the US elections until 1980. And in 1980, he fixed his model. He is not changing it since then for 4 decades. And he has a tallying model. He has identified 13 reasons. You see them here on the left, keys, he calls them, which drive whether people will vote for the challenger. So if any of the keys you see on the left are false, this counts for the challenger. And if there are 6 of those accumulated, then the challenger will win. Some of these keys are objective, as for example, key number 5, economy not in recession, and others need some more judgment, as for example, key number 13, the challenging party candidate is not charismatic or national hero. But Lichtman always in advance gathers the data, makes the judgment, and sometime before each election, the keys are fixed and the prediction is made. So for example, in 2016, every key that's crossed out now was false. Therefore, Lichtman's clear prediction, in contradiction to methods that didn't have a domain theory behind them, was that Trump will win. In case you're wondering now, Lichtman's prediction for 2020 is that Biden will win. The other extreme of the fast and frugal heuristic spectrum is fast and frugal decision trees. So in tallying, you give the same importance to all cues and you add them. In fast and frugal trees, you order the cues, and the first cue is cannot be compensated by all the cues that come after, and the same holds after that as well. So we're very grateful to Laura, not only for organizing this conference, but also for inventing, quote unquote, fast and frugal trees. And that was already 17 years ago, I think, in a book chapter. This example is due to Senghua, who, I don't know if he's there already or he's joining later. And this is a fast and frugal tree that can be used in multi-accident sites. So for example, at the site of the Twin Towers collapse, there were so many people in need of medical help. Some of them, that they needed to be prioritized. So they needed to be classified into categories. And here, with the round circles. You see the category. Somebody may simply having a minor issue, so we can afford to let them for a while. Somebody could be dying, in which case we need to provide palliative care. They need immediate care, they could be saved, or they could have delayed care. So you see in the exits of the tree, you have the various round circles with all these different categories. And fast and frugal tree means that every time I ask a question, there's the possibility of one immediate classification. So for example, I ask, is the person walking? And if he is, immediately we classify them as being in the minor category, and we can deal with them later. Otherwise, I ask more questions, but there's always the chance that I exit immediately after each question. So that makes the tree fast and frugal. So this is our version of a transparent decision tree. For our final example, we consider big data analytics, and we ask, how simple do you need to be in order to beat big data analytics? So Google Flu Trends was a very big thing for many years. It has been discontinued since 2015. You will see a possible reason why in the next slide. It was on from 2008. And what it could do, you could input the region in the United States that you are living in, and then it will tell you what's the current and the predicted flu activity in your region. And it was doing that by looking at an insane number of Google search queries. Somehow, we don't know how, that was not transparent, abstracting them in 45 queues, and then combining these queues linearly, but again, we were not told what were the weights in this combination. That was Google Flu Trends, and it was able to predict, to nowcast, more specifically, flu activity in the United States. So this is one of the new results in the book. We have others, but this is one of them. And these two panels in this figure show the same data. On the upper panel, you also see the observed, which is this black line. The recency heuristic, which I haven't told you yet what it is, it's this blue line with circles. And then you have the Google Flu Trends, which is this red thing. Google Flu Trends was updated 3 times. You see the times of these GFD updates with these orange vertical lines. Because every time they were realizing it wasn't doing very well, they were just revising it and typically making it more complex. So as this is the upper panel. You can probably immediately see that there are some cases in which the red line is very different than the other 2 lines. The other 2 lines track each other quite well. So the recency heuristic tracks the observed data quite well, but the Google Flu Trend sometimes fails. And perhaps you can see that more clearly in the lower panel. It's the same data, but the red and the blue lines now, they still correspond to Google Flu Trends. The red line and the blue line is the recency heuristic, but they have the error absorbed in them as a percentage error. So if you're above this vertical line that goes through the graph at the vertical line at 0, then you are over-predicting, otherwise you're under-predicting. And the heuristic is much closer to this vertical line that passes from 0. The blue line is closer to that than the red line. Okay, so I haven't told you what the recency heuristic is, because I want you to guess. So it's not a tallying, and it's not a fast and frugal tree model. It's in fact where the 2 meet, because it uses only a single queue. So what is that queue? Can you guess what is this single queue that outperforms Google Flu Trends that took millions of search queries of people and linear combination of 45 queues? Based on the name. So it is indeed just taking the most recent observation is what so for this week, I will simply predict that the incidence of flu was the incidence of flu of the previous week. And that's so far, as far as we know, better than big data analytics. We also run many controls. For example, linear regressions on the same variable that didn't make a difference, and so on and so forth. Okay. This is where we started. On the right, you see the table of contents. Let me quickly, before we go into discussion, reinforce a little bit what Gerd said. We start by making our case with vivid examples like the one we saw. We put forward our main thesis, which is that there doesn't need to be a trade-off between accuracy and transparency in the wild. Chapters 2 and 3 build on Laura's early work on rules for statistically inducing fast and frugal trees and tiling rules. But they go beyond that, using, let's say, more standard in the machine learning sense rules for statistically inducing fast and frugal trees. Then chapter 4 has a systematic and intense model comparison of these fast and frugal heuristics with machine learning models, and especially those machine learning models that were designed in order to be transparent, in the sense that machine learning researchers think a model is transparent, such as decision lists, Bryman's, card trees, and so on and so forth. And random forests, even though those are perhaps not so transparent. And also support vector machines, we also consider non-transparent models as well. Chapter 5 does a similar thing, connecting to cognitive psychology, but here the goal is a little more descriptive. We consider what fast and frugal heuristics can offer for understanding the processes underlying human classification, and contrast that, for example, to exemplar models. And finally, chapter 6 is important because it shows another advantage of these methods, that they do not need statistical, well-defined numerical data to be induced, but you can induce fast and frugal trees by working with practitioners. So we call it the practitioner method, and we present two of the known applications with the Bank of England and in managing security checkpoints. And then finally, we conclude. And now we're waiting for the book cover. It's a pity. We just missed it. I think we're going to get it next week. That's what the MIT Press has said. Thank you for listening. I hope it was, you could see it, and I hope you could hear us. And now, I guess, I'll leave the screen on, and I'll move the screen a little bit so you can also see Oscar is right here. And we can have a discussion. You can see Ulrich and Laura, right? I should stop sharing.
I have many questions, but I don't know.
Do you have to go to the bathroom to ask questions?
We have still bad.
Lara, there was a lot of echo now that.
Yes, yes.
But we could hear you.
Again, there's still some echo, even more. Is there still some echo?
Yeah, but it's okay. We can understand the
But
question.
here there is a lot of noise. No, I got one.
You look like me. That's very weird. We see Ulrich possibly getting ready to do something, but nothing is happening.
Okay.
Gerd, we can hear you perfectly.
Yeah. Let me step in if the technology doesn't work. I would like to make a comment on the example that Konstantinos gave about the elections. So who will become the US president? Konstantinos, could you show this again? Okay, here. There is one interesting difference between, say, a big data machine learning system that Silver used and this type of tallying heuristic. So remember, there are 13 keys, so basically Qs, as we say, and the rule is if more than 6 are negative, then the challenger will win. That's a tallying rule. And the what Konstantinos showed with the crosses, that if we do now the prediction for Trump versus Biden, so incumbent party mandate, so the incumbent party holds more seats in the House of, so that's one negative. And nomination contests, and so you can go through these things here and end up with 6 or more negative reasons, which predicts that Trump will lose and Biden will win. The interesting thing about that is, I think something different. Namely, this system provides a kind of theory about the American voter. So if you look closely at these 13 keys, 12 of them are about the candidate from the incumbent party. So if you, and only one, the last one, challenger charisma, is about the challenger. So if you apply this system to the last election in the US, Hillary Clinton versus Donald Trump, then this system has a theory about it. The theory is basically, it's all about the incumbent candidate or the incumbent party. According to this theory, Trump didn't win because he was Trump. He won because people disliked the Obama administration, or enough people disliked it, and including the candidate, Hillary Clinton. So I want to emphasize that because the tallying system with the precise cues gives you a theory about voting. It can be wrong, it can be right. If you read Silver's discussion about his big data models, he's very open about that these models depend on lots of assumptions. For instance, the distributions, what data he's taking, what is not taking, all the things that do not matter in the Lichtman system. And when Silver discusses voting, it's all about distributions, whether they are skewed, whether they're fat-tailed. It's all statistical concept. There's very little content in it. And this is also another difference between a tallying heuristic and big data. It's not just that we are, this is here, faster and frugal and transparent. it's also that it's based on content, whereas the big data machines are just number crunching. And so I just wanted to point out this aspect of the system. And we can see here very clearly whether it worked or it did not work. While in the Silver, Silver is very open about that he would have calculated very different probabilities for Hillary Clinton winning something between 60 and 100%, depending on the statistical assumptions he made. And that's a very different approach to voting than the keys to the White House.
We hear you perfectly now from the bathroom. Yeah.
Do, but if you have mammography and ultrasound, then it starts getting more complex, but our trees were very simple. You just looked at sensitivities or predictive value and you ordered in some way, for instance, ranking them. So that was both simple, transparent, and easy construction. You could do it with pencil and paper, so everybody could do it. Then there was a progress in many senses, and as you said, fast and frugal trees as they are now are complex in construction, but you don't see it because you only see the result. The machine does the work for you, and simple to use and transparent also. So I would like you to discuss a bit about this progress in many senses to having fast and frugal trees which are not transparent in construction. Not anybody can just follow the patient with the doctor, but still are transparent in the way they work and can be understood. What do you think about this progress? I know what I think, but I wanted to know also your opinion, this incredible progress in construction.
I think, first of all, I remember when I first joined ABC, I was very happy when Gerd was explaining how it was very nice that within ABC we had this agreement. And in the various papers and books we wrote, the points of view that finally make it to the paper, it's a fusion, integration of different authors' points of view. And I think that was the same in that book. I invite Oscar and Gerd to say how they felt about it. My personal, the way I always approach fast and frugal trees and other heuristics is that to get inspiration from psychology. That's what attracted me. I had training in the mathematical models from the operational research point of view. And I was very interested to see the other ideas which start from the human behavior, science inside, as we're studying. And somehow I continue to be more interested in that. I continue to be more interested in fast and frugal trees that are very simple. Somehow I like that more and I want to explore how far that can go. I think that's valuable and that's less explored than other things. On the other hand, it's completely fine to derive something completely based on computational consideration. And the chapters 2 and 3 of this book, as I said before, make heavy use of other ideas that are used in machine learning and cards for inducing trees, which are entropy and things like that, and we explain that very clearly so everyone can do it, also with the use of software. And as I said before, also chapter 6 goes the other way and it taps on this tacit knowledge of practitioners to induce the trees like that. But Laura, I know since we first met 20 years ago, we started having these discussions. I know where you stand. I think history is important, but you also have to look.
I don't want to use the question time, but I want to tell you that actually we have tried to bring Fast and Frugal Trees into school, and we are surprised. They love to use R. So the truth is, I come with sensitivity and validity and these things and construct the old way, but they are happy to use all the stuff. So it's me who is the old lady, because students, even in schools, are enthusiastic about using things that they find in the internet. So you're absolutely in fashion. So, using, there is this program, there are several things you can use now. And Philips did some good work for constructing Fast and Frugal Trees, and they are simple to use. So the important thing now is not so much the transparency of understanding every single step, as I thought back then, 20 years ago, but to be able to use a tool and which produces very transparent things. So you use the tool, it's a little black box, you believe that all things are right, and you're very happy with the production. So I agree with you today, very much.
So, Laura, can I add something? I
Yes.
just want to say there's an R package coming out with the book that's free, and you can replicate everything we've done in the book, and you can also, people can build their own custom Google trees
Yeah.
for their own data. And also we give in the book, it's actually quite transparent. We start with in chapter 2, what if you had only one cube? And so it discusses what you would do there and how you would do the different options. And then what if you had multiple cubes, and how would you order them? So the construction process, we don't just give a machine learning algorithm. It's a very step-by-step, trying to explain the logic behind, how would you approach it? And I think so we give multiple algorithms, and the simplest one we give, it's not as simple as yours, because if I remember correctly, yours were naive.
Very naive, completely
Yeah.
naive.
Yeah, so we did the greedy version, which is you consider, so you do the first layer of the tree in exactly you would do, but in the second layer of the tree, we consider what happened in the first layer. So
Yes.
we eliminate, so.
Conditional on the past, yeah.
So that's the only difference. But then, of course, there is a machine learning component to the book,
Yes.
and there's a whole chapter on it. And there we compare machine learning, highly statistical decision trees with Fast and Frugal trees. And there we use more sophisticated methods of fitting, finding Fast and Frugal trees. So it's a spectrum that we present, but I do hope that we followed also your earlier work on this in making the process as transparent as possible, the building. So there's a big discussion of that.
Yes. Let me just say what. Yeah.
Very quickly, because I forgot to say, and I was surprised Gerd didn't also correct me. Because Laura and Ulrich are here, who I think wrote the first, in a sense, journal paper on ecological rationality, the 2002 theory decision paper. The book also has a fair amount of information on ecological rationality, where we also explain how the various results we get, and there are many results that could explain through the bias, currency, composition. It's Henry, of course, brought up.
Great. So, and the book also tells you how to do it. So it's also instructional. Anybody can learn, and you have QR codes to go to the.
No, we don't have QR codes, but we. No, so yes.
But you give links. You give links so that people know where to go and download whatever and use. That's very good.
By now, I think there's at least 3 resources. The one that the R package that Marcus and Osgur prepared for this book. Nathan Phillips, Out of Constance, right? Wolfgang's book, that's already there, and sometimes I even get queries about that. And also what Uwe used to have in the old days, that is still available in the adapted toolbox website.
All right, so Ulrich also has a question.
Yeah, first, thank you, Konstantinos, for this presentation. And of course, thank you all the authors for writing this book. I find it very exciting, and I'm looking forward to reading it. I think it's an important book, and yeah, great, thank you. I have a rather technical question on tree construction. So you had again in your presentation this old discussion, telling versus fast and frugal, so compensatory and non-compensatory, so this came up here again. And
little question, because some people here are not constantly with us, could you just say very briefly what tallying is? And
they said it. Telling means to count.
to count.
Okay.
Good. Thank you.
Yeah. Okay. So and this was this discussion either or. So now we all know the green and mare tree, and those who do not know it, you can read about this in the literature. It's often used. I'm not going to answer this now. But there we have this interesting yes, no, and then comes this compound queue. Is one of the following 4 or 5 queues present, which is, let's say, a tally rule within a fast and frugal tree. Of course, you can now say, since you're asking, is at least one present, you could still represent it as a fast and frugal tree, meaning you could theoretically ask one of these 5 queues each after the other, and you still have a strict fast and frugal tree. But if the question were, are at least 2 present, or are at least 3 out of these 5 present? And in the example you gave, the question was, are at least 6 of the 13 present? So my question is, did you look into the possibility of combining the fast and frugal approach, the lexicographic, non-compensatory, and the compensatory approach? Did you consider a fast and frugal tree that have these tally components implemented?
No, not in the book, but we did write about the connections that from Italian and fast and frugal tree, some decision rules can be represented as either, right? The same rule you can present as a Italian rule sometimes and also fast and frugal tree. So we did write about the connection, but we didn't consider the combination of the rules, if I can do that.
But it's a great question, Ulrich, and we also struggled about that.
I just go to the loudspeaker, sorry.
Yeah, okay. It's a great question. We thought, is it still a fast and frugal tree if one person includes 2 queues? We thought about that and we make some comments. And this is a very important question. I think it's something that makes fast and frugal trees more transparent in general if you constrain them to only have 1 queue per question. And it's something that doesn't exist in Breiman's trees or in the other machine learning models. You can have one person that's very complicated in itself. And in the book, somehow we tiptoe a little bit around it, and we suggest that people try to keep each question as simple as possible, but sometimes you can also make it more transparent by having a couple of trees together, as in the green and mare tree. So I think we could be thinking about that more.
Yeah. I think the critical thing is when you look into this is you run into computational explosion. So in the work with Laura in Frontiers or also with Jan Woike, we discussed construction principles. And there it was very simple to construct a fast and frugal tree. You just do the sensitivity calculations and all this PPV calculations on a backside of a napkin. Once you consider compounds, then the question is, when do you compound, how many, on which order? And then it explodes. And this is no longer the spirit of fast and frugal. There a napkin would not longer do the work.